This is part 2 of the Euler's method video. The video for part 1 ended with this table here, the shortcut that I showed you, and it ended with this visual showing how you jump from line segment to line segment, connecting P0, P1, P2, and P3. In this case, all of our approximations are a little bit below the actual y values. I'm going to give you one more example because with this potential snowstorm, I know you're going to be stuck inside. Calculus is the best way to keep yourself busy on a boring snow day. So here we're actually going to do a couple more, well, one more step in the previous one. I have a new differential equation for you. This time, this one is not separable. So what we're doing is actually going to be useful because we couldn't do this with separation of variables. I'm giving you an initial condition here and giving you a step size. And I'm saying, all right, if you start at 0, I want you to approximate the y value at 0.4. So you might be thinking, all right, if I jump by 0.1, that means I have to do this 4 times. So I set it up for you here. I'm going to partially do it out with you and partially do it ahead of time just to save some time here. This is my initial starting point, p sub 0, and it's at 0, 1. So I'm going to get tangent line at 0, 1 to ride it along for 0.1 along the x-axis. This time, make sure when you find dy dx, you actually follow the rule of what dy dx says. I'm not multiplying them this time, I'm adding them. X plus y. My slope is 1, so I'm going to follow a slope of 1 to start at p1 and get to start at p0 and to get to p1. So to find the y value at p1, I use the y value at p0 and I add the product of the slope and h. So y1 is my very first y value, which was 1, plus the slope I just found, which was also 1, times my step, which is h. So 1 plus 0.1, again, it's 1.1. If I start at 0, 1 and my step size is 0.1, that means my x value is going to increase by 0.1, jumping me to 0.1 now. My new y value goes here. Now I'm going to get a new tangent line at this point. So I'm going to go from P1 to P2. To go from P1 to P2, I need to ride along a tangent line again. To get a tangent line, I need a point and a slope. I have a point, I need a slope. I plug in my slope formula, and I get 1.2. So to get the y value for P sub 2, I use the y value of P sub 1, and I add mh. So y2 equals y1 is right here. So 1.1 plus the slope I just found, 1.2, times my step size. On your calculator, you would do that out, and you would get 1.22. Now that I have the y value for the P2, I know that the x value for P2 is this x value for P1 plus 0.1 because that's my step size. I plug in again to get a slope to ride along to get to 0.3, which I already know is going to have an x value of 0.3. And I'm getting really close. I need to get the 0.4. Let's get this y value here. y3 is y2 plus mh. y3 is y2, 1.22, plus the slope I just found, which is 1.44, times h, 0.1, and I calculated ahead of time, I got 1.364. This guy goes here, 1.364. One more time, then we're there. So last iteration that we have to do here is to go from 0.3 to 0.4. I found my third y value, I plugged it in, I found the slope that I'm going to use to follow along from 0.3 to 0.4. The slope of this tangent line is 1.664. So my last y value, which is the y value that I want, is the previous y value plus the slope times 0.1. So hopefully by now you're getting the hang of this. It's the same iterative process over and over again. 1.5304. So I now know that P sub 4, which is x sub 4, y sub 4, is 0.4, comma 1.5304. So here's your answer for an approximation to y sub, or y of 0.4. I'm going to show you a table again of how to organize everything. As you do these problems out, when you do them on your own, you can do a table the whole time, not just at the end, or you can completely omit the table. You never have to make a table. It's completely up to you, however you're more comfortable doing it. This is the number of iterations, so I'm starting initially without any iterations at the ordered pair 0, 1. In order to get to 0.4 with an h step of 0.1, I need 4 iterations. And these were the y values we found first: 1.1, 1.22, 1.364, and 1.5304, with this being the final answer as an approximation to y of 0.4. Now that you've seen 2 examples fully done out, I want you to try this third example in your notes. I want you to show your workout. I'm giving you a differential equation 2x plus y, an initial condition 0 or 1, 0. Here's your step size of 0.5. Approximate f of 2.5. Now to go from 1 to 2.5 with a step size of 0.5, you'll be going from 1 to 1.5, 1.5 to 2, and 2 to 2.5. So you'll be doing this 3 times. Not too bad. If you want to use a table, but either way, I still need to see your computation work. Enjoy your snow day if we have one. If we do have one, I'm going to give you a set of problems to do, which we would be doing in class Monday. But either way, we'll be practicing this Monday, whether it's in class or at home. Bye.